So if you've looked at the calendar, let's see. Okay, here we go. Oh, that's a quiz. We don't want to do that. Okay, so this looks familiar, right? Okay, has anybody clicked on the textbook button? Okay. So you don't have to bring your textbook to class very often, and this apparently didn't work. But if you click on this, I mean, you've got to help me solve this in the view and example. But if you click on the textbook button, normally, although apparently not always, it will bring up the pages in the textbook that correspond to that. So you can look through the textbook examples and stuff like that. So just wanted to make sure you were aware of that. It also has a calculator on there sometimes, and then there's the print button that you can use. So we're going to go over 3.3 today. So I'm going to pull that up. And then has anybody looked at the calendar lately? We have a test a week from tomorrow. Okay. Notice anything else about the calendar? Mm-hmm. Yeah. Okay. So I'm going to pull up the calendar also, just so we can take a look at that. So we're going to start 3.3 today. We'll probably finish it tomorrow, and then we'll have probably a short quiz either at the end of class tomorrow or at the beginning of class on Thursday, and then we'll cover 3.4. This will be a Q&A day, a recitation day, whatever you want to call it, office hours, and then review here, and then the exams right here. But what about these guys right here? We haven't seen these up here. Okay, we're going to start Project 1 tomorrow. Okay, I'll show you where you can download that, what you need to do with that. We'll get in groups and that sort of thing because it is somewhat of a group assignment there. You're going to get that tomorrow, and then it's due next Tuesday. So even though we've got some Q&A days, and we really only have, I mean, in the next week and a half, let's see, what are we talking here? 7 days. We really only cover 2 new sections. We do have some other stuff going on, okay? If you've had a general education class at the community college, you know that they require that e-portfolio assignment, that signature assignment. So if you don't have an e-portfolio website, you'll need to make one and upload that. Make it pretty easy. You can use the copier or ask one of the ladies in the office, Camille. They've got scanners. They can scan a document and email it to you, and that way you can upload it to your website and stuff like that. So we'll get there. So 2 sections to cover, a project to work on, some review, and then a test a week from tomorrow. Okay, everybody clear on that? All right then. Okay, I'm gonna, if you'd just read those first 2 paragraphs there while I pass this out. Yeah. Quiz will be end of class tomorrow, or most likely it'll be on Thursday. And it's not a huge deal. It's just kind of to get you ready to take the test.
Is it going to be online or paper?
It'll be paper, yeah. Remember, all the reviews and all the tests you do paper and pencil in class, okay? Okay, so I had somebody over the weekend, actually 2 people, say to me, and these are people in their 40s or 50s, they said, you know, I kind of liked math, but it always drove me nuts that I could never see how it applied, or it felt like everything I was doing was busy work. I never actually learned to solve any problems. And so I talked to them about some of the things that I do in my class to, you know, help people see where they can apply it. But a lot of the math that you learn is just, we call it preparatory work. It helps you learn stuff that helps you figure out the really cool stuff down the road. I mean, you have to know a lot of math before you get to a point where somebody would pay you for what you know in math. But we do get to that point a little bit, starting probably in college algebra, a bit more in calculus. But really, to make a good living at it, you got to know a lot more math than even calculus. So to be an engineer or something like that. So what I start this off by saying is, I mean, everybody complains, or most people complain in their pre-algebra or algebra classes about showing work. Why do I have to show the steps on both sides and all that sort of stuff? Hey, can I get everybody to close their computers? Or I'll put a warrant out for your arrest. There we go. So everybody complains about showing their work, showing both sides of the equation and all that sort of stuff. And there are problems where you can get the answer just working through it in your head. But if you don't know how to show your work on the easy stuff, when you get to hard stuff that cannot be solved in your head, you've got to be able to rely on showing the work. It's called analytic work, paper and pencil work, the algebraic work to support your answer so that you can solve those more complicated problems. Or if you don't learn how to show the math show your work on the easy type of math, when you get to more complicated things, you're not going to know how to show your work there either, okay? So you're not going to be able to solve those types of problems. Well, this is where we get to the point where you're going to see some problems where occasionally you run across a story problem where you can solve it in your head, but most of the time you can't, okay? And that's the way these problems are. Your job in reading these, and these are pretty much all story problems, is to read through them, sift out enough information that you can write down a system of equations, because this is an application of system of equations, so that you can write down those two, solve it, and then state what the answers are. We're going to be choosing variables. It's generally a good idea to choose variables that remind you of what you're looking for. So if we have a problem that's about hamburgers and popsicles, we might choose H for hamburgers and P for popsicles. Okay? And as we go through it, it might have information about how many of those we sold and then how much they were worth. So we might write an equation about the number of hamburger buns or whatever it is in popsicles, okay, and then the amount of money that generated. So we're going to be kind of going at it that way. So we're going to look at this first problem right here. So you've got a copy of this, right? So these are problems out of the textbook, okay, not all of them, but most of them, or problems on the assignment or like the ones that are on the assignment. And I don't think the assignment is terribly long, but it is important that you're able to solve these. I can absolutely guarantee that you'll find something like this on the test, okay? Next week, the test. You'll definitely find some on the quiz in a couple days, but you're going to find these on the test. So we want to read this carefully, and let's run through this. So it says, in order to make a necklace, a jewelry designer purchased 80 beads for a total of $39. So bought some beads for 39 bucks. Some of the beads were sterling silver, and they cost 40 cents each, and the rest were gemstone beads that cost 65 cents each. How many of each type did the designer buy? Now, the interesting part about problems like this is there are lots of different ways to approach it. You might approach it one way, and your neighbor approaches it another way. You might write down things in cents, and they might keep track of them in dollars and stuff like that. So the important part is there is enough information to solve this. In fact, there's enough information to write down two equations. So let's read that first sentence right there. It says the jewelry designer purchased 80 beads for a total of $39. Okay? Now, contained in that is a lot of information. She purchased 80 beads for $39. Let's keep reading. Some of the beads were sterling silver. They were 40 cents each. And the rest were gemstones. They were 65 cents each. So we really have two pieces of information, or two groups of information going on here. We're talking about how many beads did we buy, and how many of each type, and how much was each one worth, or how much were they worth in total, okay? So we're going to write one equation about beads, just the number of beads. We don't really care about how much they were worth. And then another one about how much, or we're going to say this, just to make it plain and simple. We're going to write one equation about the number of beads, and the other equation is going to be all about the money in the problem, okay? How much things are worth. So if we're just talking about beads, we've got sterling silver beads, and then we've got gemstone beads. So silver and gemstone. Now, do we know how many sterling silver beads there were? Nope. Okay. What do you want to use to represent sterling silver beads? S. Okay. And for gemstone beads? we'll use G. Now, we don't know how many sterling silver beads there were. We don't know how many gemstone beads there were. But we do know that altogether,
There's 80.
80 beads. So if I take the sterling silver beads and add them to the gemstone beads, I get 80 beads altogether. This one is all about beads. Now let's write down one about money. Now, if they were 40 cents each, and I bought, let's say I bought 3 of them, how much money would that be? 40 cents each. I buy 3 of them. How much? $1.20. How do you figure that out? You multiply, right? You take the number of beads and multiply it by their price. Well, we don't know how many silver beads they bought, but we do know that they're 40 cents a piece. So let's take that and let's multiply it by 0.40. So 0.40s represents how much money was spent on the silver beads. How could I represent how much was spent on the gemstone beads? 0.65 G. And if I take the money that was spent on the silver ones and the money that was spent on the gemstone ones and I add those together, how much money did this person spend altogether? $39. Okay, now, here's what you've got to be careful with. Everybody watching, please? Okay, I'll tell you what to be careful with in just a second. Are there any questions or does this make sense and seem pretty easy? Okay, then let me show you some pitfalls, some mistakes that people make. So one mistake people make is they do this. They say, you know what, I'm going to represent that with 40 cents, so I'm just going to write 40S, and I'm going to write 65G for 65 cents per gemstone bead. Okay, and then I'm going to write $39 over here. What's wrong with this? McKay?
If each cent equals 1, then the 39 would have to have 2 more zeros.
It would have to be much bigger. How many pennies, how many cents in $39? Well, you'd have to times it by 100, it would have to be 3,900. If you were going to do this one without the decimals, okay, by putting the decimal there, we're saying $0.40, $0.65, and $39 if we put the decimal there. Okay, does that make sense? So please make sure that if you're talking about money, you keep your units straight. If these are in cents, okay, this has got to be in cents. If this is in dollars, these have got to be in dollars. By the way, what are they in right now? Cents or dollars? They're in dollars because we put the decimal in there. Everybody good with that? Okay, so I kind of like solving it like this, okay, although you don't have to. If you want to do 40, 65, and 3,900, that's totally okay with me. Okay, another mistake that people make is they'll put 0.4s and they won't leave that placeholder there. If you're talking dollars and cents, save a place for where the pennies would go. Okay, so this is 10 cents. This is the 1 cent column, if you will. That's just a good placeholder. Okay, it comes in handy when you're adding and subtracting. Okay, are there any questions? Is everybody okay if I solve it like this? Okay, we're good. Okay, is this set up for? Gosh, what were those 2 techniques that we learned last week? Elimination and substitution. Which is this set up for? We could set it up with substitution. Okay, we could solve for one of either the S or the G. Both would be pretty easy. I could plug into the other one, and then I could solve for the remaining variable and then plug back in. Okay, I kind of like elimination if it's possible to do that. Now you're going to have access to a scientific calculator, so the decimals shouldn't be too scary. So here's what I'm going to do. I'm going to eliminate one of the variables, and the variable that I'm going to eliminate is the S. So I need to make this not a 1s, I need to make it a 0.40s, and I need to make it negative. So I'm going to multiply this one by negative 0.40. So if I do that, I get negative 0.40s, I get negative 0.40g, and over here, gosh, I've got to do negative 0.40 times 80. Well, if you can do that in your head, that's great. Hopefully you can, because we're just doing 4 times 8, that's 32. And then we take care of the decimals and the zeros. It actually is 32. Everybody okay with that? Yeah. It is negative. Thank you very much. Appreciate you catching my mistake. Got it? Any questions? Okay, we're now to the point where we can add these together. And this is the great thing about elimination. When I put these together, you can see they go away. Even though decimals aren't our favorite thing to work with, you can see that they go away. And then something cool happens here. What if I take 0.65g and subtract 0.40g? 0.25g, right? And I can do 39 minus 32, that's going to be 7. Okay, let me just make you aware of one more pitfall, why I think it's important to put the 0.40 there. Everybody watching? Okay, some people will do this. If you don't leave that decimal there, they'll do minus 0.4. They'll write it like that, which is technically correct. That's still 0.4g. But when they subtract, they'll do this. They'll do 0.65 minus 0.4, and they'll do 0.61g. What did they do? Yeah, Parker.
4 is in the same place as the 6 on 5.
They didn't have that placeholder in there, so they subtracted the 4/10 from the hundredths column, basically. Okay? So you don't want to do that. That's why it's a good idea to leave that in there as a placeholder. This is correct. Now, if you need a if you need a calculator for this, that's fine. What is 0.25 of a dollar?
1/4.
It's 1/4, or we call it a quarter, right? If I divide both sides by 0.25, the cool thing about this is you can do this in your head. How many quarters are there in a dollar? 4. How many dollars do we have? 7. 28. Now, notice this. This produces an answer of g equals 28. Now, if you chose your variables wisely, what does g equal 28 mean? 28 gemstone beads. Okay? So 28 gemstone beads. Okay? Well, if there are 28 gemstone beads, at this point it's hardly even a math problem. Gosh, if there were 80 altogether, I'm just going to take 80 and subtract 28, and that's going to give me 52, right? Or if I did it by substitution, here's technically what we do. We take the 28, I plug it in right there, so I have s plus 28 equals 80, and then I end up subtracting 28 from 80 either way, and I get s equals 52. S, of course, stands for the silver beads, so we'd say there are 52 silver beads. Okay, now, I don't think I could solve that in my head. If I thought about it a while, I could probably keep this stuff straight in my head, but I wouldn't want to do that on a test. And if it got any more complicated than this, because this is a fairly easy problem, if this had even been 30 cents rather than 25 cents, I wouldn't have been able to do that in my head. Okay? So I wouldn't expect anybody in here to be able to do it in their head. Okay? And even if you could, why would you want to show work? Why would you want to show work on a fairly straightforward problem like this? To make sure you get the right answer. Okay? That would be important on assignments and on tests. What else? Yes? In case you make a mistake, you know how to fix it. And what was the reason I went over at the beginning? These are pretty straightforward. Are we going to get to the point where there are problems you cannot solve in your head? Okay, you couldn't even keep all this straight in your head. Okay, so you've got to be able to write down the work on these easy problems so when we get to more difficult problems, you can actually solve them. Okay, now the ones today, pretty straightforward. Okay, the ones in 3.3, they're not that bad. Later on in the chapters, later on in the course, we're going to get to some ones that are pretty interesting. Okay, are there any questions on that one? Okay, let's look at the next one then. Okay, this one is about student loans. This one was taken from the textbook. Stacy's 2 student loans totaled $12,000. One of her loans was at 6.5% simple interest, and the other one was at 7.2% simple interest. After 1 year, she owed $811.50 in interest. What was the amount of each loan? So we want to make sure we're clear on this. Just a quick reminder. What's the formula for simple interest? I'm sure you've all seen it before. Yeah.
Isn't it like the percentage times the initial dollar amount?
Times the time. So we call it this. The amount that we have, that we take out, it's called the principal. The interest rate we call R, and the time that we take it out for we call t. So it's PRT. Simple interest, I equals PRT. Principal, that's the amount of the loan. Rate stands for interest rate, T stands for time. So again, you've got to pick out enough information that you can write down two separate equations. Okay, take a look at this right here, just the first sentence. She took out 2 student loans. They totaled $12,000. Yes?
X plus Y equals.
Okay, Tyler is suggesting X plus Y equals 12,000. Now, you can use X and Y. We could do F for first and S for second or something like that, but X and Y are fine. We should, it's called declare variables. Okay, so we'll say X is at the 6.5%, and we'll say Y is at the 7.2%. So we can keep these straight. The X, that represents the dollar amount taken out at the lower percentage rate, and Y is the dollar amount taken out at the higher interest rate. Okay? So we're going to write one equation about, and this is what it is, loan amounts. And the other equation is just going to be about the interest. Now, the structure of this problem is going to be very similar to the one we did just a minute ago. So, took out X amount, took out Y amount, add them together, we know she borrowed $12,000. This one was at 6.5% interest. So if I borrow $100 or even $1,000 at 6.5% interest, how do I figure out how much interest I owe?
Equals GMT.
Yeah, the interest is going to be equal to the amount I borrowed, which we're going to call X. What's the interest rate? 6.25. And what do you have to be careful about formulas and percentage rates? You have to put them in like this. Nope, got to put them in as a decimal. So we're going to do 0.065. And then what was the time? How long did we leave the money in there? How long had we had the loan out? 1 year. So here's the cool part about this. The interest on these is really easy to calculate. It's the amount we borrow times the interest rate times 1. So it's really just 0.065 times X. Want to take a guess at what the other one is? 7.2% would be 0.072y, and that should equal, remember, that first equation was about the loan amounts. That amount plus that amount should be $12,000. This amount of interest plus this amount of interest should be $811.50 in interest. Okay, so this is 811.50. Okay, are there any questions about the setup for this problem? Okay, then I want to mention two things and then we're going to solve this. Okay, the first one is you can write this down another way. There are some people that don't like working with these small decimals. So what they do is they move the decimal over 3 places on each one. In that case, the equation would be 65x plus 72y, and that would equal 123,811,500. Okay? Now, if you like that better, then use this equation and that equation and solve that. Substitution, elimination, I don't care. Okay, I happen not like that. I don't mind working with decimals like that. And a lot of times it works out pretty easily, and we keep the numbers fairly small. Doesn't matter to me, that's just my personal preference. I like this setup better than this blue setup over here. Any questions there? The second thing is, okay, does everybody still have everybody? Compare this problem with the problem we just did. Aren't these set up almost identical? It's almost exactly the same thing. We're just talking about loan amounts here rather than beads. Good? I can't solve this in my head. I can't even come close. It would be very, very difficult to even come close. So if we can't set up that previous one and have this algebra work to fall back on, we're not going to be able to solve this one. Okay? All right, so let's go ahead and solve this. I am going to solve it using this. And all I'm going to do is, for some reason I like getting rid of the first one. It's just kind of the way I am. I'm going to multiply this first one by, going to get rid of the x. It needs to be negative, and I need it to be the same number, so I'm going to multiply by 0.065. So this is negative 0.065x, negative 0.065y. See how those still line up? And then this is going to be negative. Now I do need some help here. I need to know what 0.065 times 12,000 is. So we crack out the calculator. Now again, if this is on Math Excel, you're going to have that calculator available for you to use. So this is going to be 0.065 times 12,000. Make sure I've typed it in correctly, and the answer is 780, and it's negative, okay? So negative 780. I'll then add those together. Gone here. The cool thing about this is still relatively easy arithmetic because we've got the placeholders in there. This is going to be 0.007y. And then over here, I probably would use a calculator for this, even though this isn't this 3150? Is that what it is? 81150 minus 780?
Yeah.
3150. And then really the only other part of this problem that I need a calculator for is I'm going to divide by 0.007. Throw that in the calculator. So I've got 3150, 0.50 divided by 0.007, and it kicks out an answer of 4,500. Now, if I just wrote down y equals 4,500 and circled that, is that the answer to the problem? It's not. Okay? Because we have to come back up here and we have to remember, what is y? Y is the amount that she took out at 7.2% interest. So what we'd say is, to answer this question appropriately, what we really should do is, we should say $4,500 at 7.2%. And let's figure out what the other one was. Well, let's see, 12,000 minus 4,500 is going to be 7,500. Am I right? So $7,500 at the other loan amount. Okay? Now, let's take a quick look. It's always a good idea. Most story problems end with a question, and they tell you what they're looking for. What was the amount of each loan? Well, look at the way we've written this answer. Can you look at it, and does it truly, I mean, if you were reading this, could you ignore all the work and just say, oh, $4,500 at 7.2%, $7,500 at 6.5%? There's the answer, an appropriate answer to the question. Good. Any problems? Good? Okay. I am not quite sure why, but for some reason, authors of textbook, they like to include really funky names, and when they start making stuff up for story problems, they get all these wild things going on. So this one's a little bit crazy. So Teapots and Treasures. Apparently a nice little store you could go into. Sells loose oolong tea for $2.15 an ounce. Donna mixed oolong tea with shaved almonds that sells for 95 cents. I don't drink tea, but that just sounds like a nasty mix to me. To create Market Street Oolong Blend. So she's putting a couple things together that sells for $1.85 an ounce. 1 week she made 300 ounces of Market Street Oolong. How much tea and how much shaved almonds did Donna use? So notice that it's a good story problem, other than all the funky words. It ends with a question. It says, how much tea and how much shaved almonds did she use? So we're going to need to write a couple different equations here. Now notice what's going on. We've got some dollar amounts here, okay, or some prices. So we're going to have one about money. The money involved in this little store. And the other one, notice that these three numbers are dollars. What's this one? It's ounces. It's like an amount, okay? So we're going to write one about money, and we're going to write the other one about the amounts. Now, the amount one is actually the easiest one. Once you start throwing percentages and dollar amounts or cents or whatever in there, then it gets a little more complicated. So let's do this one first. Let's do the amounts first. Do we know how much tea? We don't, right? If you don't know how much tea she used, T, what letter should we use? That sounds good to me. So we're going to use T for tea, all right? And then it says she also used, what was the other component? Almonds. So we're going to use A. Now, if T represents the tea and A represents the almond, now unlike this problem up above, do I need to say T represents tea and A represents almond on this problem? No, because we chose the variables appropriately. That's going to remind us when we get an answer A equals some amount, we know A stands for almonds, okay? Now, do we know anything about these amounts of tea and almonds?
They equal 300 total.
They equal 300 total, which means we're going to do what with the two of these? Add them together and we're going to get 300. So here's our equation about amounts. This is just purely the amount of tea, add it to the amount of almonds, we get 300 ounces. Okay, now the other equation needs to be about money. So let's think about this for just a second. $2.15 an ounce for oolong. Let's see, shaved almonds are only 95 cents. And the blend is $1.85 an ounce. So this one is a little bit more complicated because we've got $3 amounts to keep track of. Now, I want you to think of it this way because this is going to come in handy later on. Okay, if I mix something, just want you to think, don't say anything aloud. If I mix something that cost $5 with something that cost $8, how much would I charge for it if I mixed them together? If one was 8 and the other one was 5 and I mixed them together, would I charge 13? You could try that. Sarah's smiling here. Why are you smiling?
I'd charge more, just so I would have a small profit.
Okay, so you'd have a profit. Okay, so we could mix them together and charge more than either of them, or charge them if we put them together. Or how about this? If we really wanted to sell a lot of it, if one costs $5 and the other one costs $8, when we mix them together, does it make sense that the price should be somewhere in between there? A little more than $5 because you added something more expensive to the $5, and a little less than $8 because you added something less expensive to the $8 whatever. Does that make sense? Okay, so here's what's going on here. The tea is expensive, the almonds are cheap, the blend is going to be somewhere in between. Now, if she did this all based on math and just calculations, if this is $2.15 and this is 95 cents, and we're selling it for $1.85, do you think she used more tea or more almonds? More of the cheap stuff or more of the expensive stuff? More expensive, okay? McKay, why is it the more expensive one?
Because the number is closer to how much the oolong tea costs than
The final price is closer to the tea cost rather than the almond cost, okay? Now, what if you used equal parts? Where would the price be? Right in the middle of the two, okay? If you used more cheap stuff, you could sell it for cheaper, so it would be closer to the cheaper ingredient, okay? So here's how we're going to have to do this one. This is set up very similar to the other ones with one added complex part of the problem. How do we know how much she spent on the tea? It's just like the other ones that we've done. $2.15 times the tea. How do we represent how much we spent on almonds, or she spent on almonds? 0.95 times A. How do you know how much that mix was worth altogether? Okay, 300 ounces, and she's going to sell it for $1.85. So this is $1.85 times the 300 ounces. Now what I want you to look at here, we're kind of walking through this. We're going to run into problems on the next page that are very similar to this. Okay, and I'll show you how to keep track of this stuff. That one part of this problem makes this much more complex. But I want you to notice the symmetry here. I take the t, remember, this one's about amounts. I take the t, multiply by how much t costs. I take the almonds, multiply by how much almonds cost. I take the blend, multiply it by how much the blend costs, and that gives me my money equation. Okay? So let's write this down. I'm going to make this much larger so I can write it over here. So here's the equation I want to solve. T plus A equals 300. And then I'm going to solve 2.15 plus 0.95 A. And then what is $1.85 times 300? What is it? $5.55. $555. So that 300 ounces, she's going to end up generating $555 from that. And this right here is the equation we want to solve, or the system of equations we want to solve. Now, I'm not going to spend any time solving this. At this point, it should be easy. Now, I went through and I printed off the people that finished 2.5 and the people that finished 3.2. Is everybody done with 3.2, do you think? Not everybody. Okay, and not everybody had 100 on both of them. Okay, so again, if you're not in the habit of getting stuff done right away so it's done for the next class period, you better make sure you are. Okay, if you could solve this stuff in 3.2, then at this point this is an easy one to solve. If it were me, I would finish solving this by multiplying by negative 2.15 times each of these, do the subtraction, eliminate, and that would tell you how many almonds she bought, and then you could plug back in and find out how much tea she bought. Okay, are there any questions on how to set this up? Sure? Okay, flip the page over if you would, please. Okay, I'm going to try and get through these two problems. But this is a good way to set these up. So I've got this little grid here. This is called a mixture problem. Okay, so if you want to write that next to this, mixture problems are absolutely classic. In fact, you could probably go home and read this to an older sibling or a parent, and they'd say, oh my gosh, I remember doing stuff like that. Okay? So these are absolutely classic. These are problems that we learn to help figure out how algebra can help us solve problems. And if you think about it, if you worked for a fertilizer company like this one is about, you could probably get paid to figure out, you know what, we've got these different types of fertilizer, we want to make a new one, how much of each should we use so that we get the desired mixture that we want. Okay? I'm not joking, people get paid for stuff that's similar to this. Now they got to know how to do other stuff, obviously, because they're not going to sit around and do these, but good things to know how to do. So, Nature's Green Gardening Incorporated carries 2 brands of fertilizer containing nitrogen and water. That's all they've got, nitrogen and water. Nitrogen is the key ingredient. Anybody can get water. Okay? Gentle Grow is 3% nitrogen, so they've got this one brand that's 3% nitrogen, and Sun Saver is 8% nitrogen. Okay? They want to combine those two types into a solution, so they're going to mix them together so that they get 90 liters that's 6% nitrogen. So they've got one that's 3% and they've got one that's 8%. They want to mix them together so that they get a 6% solution. Okay? Which one are they going to need more of, the 3% or the 8%? Parker?
8%.
The 8%. Okay? Because right in the middle of 3 and 8 is about 5.5. We want it a little bit higher than that. So we're expecting a little more of the Sun Saver. Okay, so here's how we're going to keep track of these. Okay, we're going to keep track of the amounts. We've done that before. Okay, we're going to keep track of the percent, and we're going to keep track of, we're going to call it this way, pure whatever. In this particular case, it's pure nitrogen. Okay? If you set these problems up this way, you'll be able to solve them. Okay? Now, if you learned a different way to set these up by drawing barrels or bins or something like that, that's totally okay with me. So here's the first thing we've got going on. We've got Gentle Grow. So we'll call that gentle. We've got Sun Saver. And then when we put the two of those together, we've got this new one that they didn't give us a name, So we'll call it, you could call it the blend, you could call it the mix, whatever you want to call it. I don't care what, okay? On this one, I'm just going to call it the mixture. Okay? Okay, this is going to be an equation right here. This column will be an equation. And this column will be an equation. All this one's going to do is just keep track of percentages for us. Okay? So, do we know what percent the gentle grow is? 3%. Am I going to write 3? 0.03. What about the sun saver? 0.08. What about the mixture? 0.06. Okay? Now, all these we're just keeping track of this stuff. That's all we're doing. This isn't going to produce an equation. There's no way you're going to take 0.03 and add it to 0.08 and get 0.06. Okay? All this does is just keep track for us. So, let's do this. Do I know how much gentle grow I'm going to need? I don't. If you don't know what it is, what do you use to represent gentle grow? G. Do we know how much sun saver we need? No. So what are we going to use to represent sun saver? S. Do we know how much mixture we need? We do. It says we need 90 liters. So we're going to write 90 right here. This is an equation. Take this much gentle, take this much sun, put it together. Whoops. G plus S equals 90. Any questions there? There's an equation. Okay, I'm going to switch colors. How much pure nitrogen do I have if I've got G liters and it's 3% nitrogen? So let me show you an example. Let's say I've got this bin here. It's just chock full of this stuff. Okay? Remember, it's water and nitrogen. Let's say I've got 100 gallons and it's 50% nitrogen. Okay? So if the nitrogen settled out and I had nitrogen down here and water up here, how many gallons of nitrogen would I have on the bottom? 50, right? Okay, what if I change this? 60% nitrogen. 60 gallons of nitrogen, 40 gallons of water. What if I went with 6% nitrogen? I'd have 6 gallons of nitrogen down here and then all the rest would be water, right? How do I get that? Once I know the percent, how do I figure out how much pure nitrogen I have? We'll do it again. Let's go 10% and let's go 150 gallons. So I've got 150 gallons sitting in here and it's 10% nitrogen. How much pure nitrogen do I have? 15. How do you figure that out? Times. 150 gallons times 10%. 150 times 0.10 gives me 15 gallons. So I take the amount, multiply it by the percent, that gives me the amount of pure nitrogen. So this is going to be 0.03 G. What's this one going to be? 0.08 S. And what's this one going to be? Here's the cool part. It's not going to have a variable in it. What's it going to be? 5.4, right? 5.4. So when you dump in this much green grow, is that what it's called? Gentle grow. When you dump in this much gentle grow, you get this much pure nitrogen. When you dump in this much sun saver, you get this much pure nitrogen, and altogether you get this much nitrogen. So I take 0.03 G plus 0.08 S, and that equals 5.4. Again, this is about the amount, total amount, and this is about nitrogen. Does that make sense? Okay, look at these two equations. Can we solve this system of equations now? You bet we can. Okay, so I'm going to take this, make this a little bit larger, and let's see what we've got to solve. I'm going to have 0.03 G plus 0.08 S equals 5.4, and I'm going to, I just like eliminating that one, so I'm going to multiply by negative 0.03, negative 0.03 G. negative 0.03s. And this is going to be, let's see, if I multiply those together, I'm going to get a negative, and it's like 3 times 9, which is 7. So I believe this is 2.7. Correct me if I'm wrong. Is that okay? And then again, you can just continue doing the math. The g's go away. This is going to be 0.05s, and this is going to be 2.7, I believe. It's positive. Divide by 0.05, and the cool thing is I think this goes in evenly. So if you take your calculator and do 2.7 divided by 0.05, what do you get? 54. Okay? Now, we've been doing a bunch of math, not really thinking about fertilizer or anything. What does that mean when we say S is equal to 54? 54 liters of Sun Saver. Let's see, the other one was 90, so I'd take this and plug it in, subtract from 90. So 90 minus 54 is going to be 36. So 36 liters of Gentle Grow. And there's the answer to the problem. Okay, are there any questions? Okay, so here's what we're going to do tomorrow when you come back. You have enough information that you can get started on the assignment. When you come back tomorrow, we're going to finish this problem right here. Okay, it's very similar to the one above. In fact, what I would like you to do, everybody listen please, try and get started on the homework and do this problem right here. It's almost identical to the fertilizer problem. It's just they're talking about something more pleasant, and that is chocolate. Okay? And then I'm going to show you how to do these other ones. I've got 2 more problems to do, and then you can have the rest of the time to work tomorrow. So, quiz will be Thursday. Tomorrow we'll finish this up, and you'll have some time to work. Quiz will be on Thursday. Since we're not done, this isn't due tomorrow, but should you get started on it? Yes. Absolutely. Okay, have a great day.